Hello and welcome to solving rational expressions. Okay, so this problem, you typically see this problem in maybe pre-alg or alg 1 a lot, and when your teachers probably teach you guys this problem, they probably tell you guys to do what is called cross multiply, and it works fine. And I'm not against cross multiply, but cross multiply is kind of like a unique situation where if this certain scenario happens where you have one fraction equal to another, you can do cross multiplication. Yeah, so it works in a I don't really want to say a rare situation, but um, when you get to higher level math, you're not just going to see this happening. So the technique I'm going to show you guys instead is going to be very similar to when I showed you guys subtracting fractions, yeah, or subtracting rational expressions is what they like to call it in technical terms, but basically subtracting fractions. So when you see me doing some of the steps for this problem, you're going to say, wow, this looks just like what you did when we subtracted the fractions. And I'm going to say, yeah, that's why I like this way better, because it brings more familiarity to you, yeah, the students that always think that we're on a different problem. So it's a brand new technique that has a whole brand new scenario and a whole brand new process, and you have to do all these unique ones for every single different look. And it can get intimidating, so that's why I want to try to keep it as simple as possible, where you don't have to use different techniques for all these different problems. You just got to use the same thing, except the only thing is you got to know that this technique belongs to this problem as well. Okay, so rather than getting on about the background of it again, I'll just start doing it so that you guys can say, oh yeah, this does look familiar. Okay, so the first thing I want to do is I want to surround the x plus 5 and the x minus 2 with parentheses so that you guys know that they are a group. They belong to each other. Okay, all right, so actually, this is a good time to do domain restrictions because, yeah, I always do my problems and I forget about them, then I eventually never address them, so that's kind of bad. So, yeah, let's talk about domain restrictions. So let's see, what kind of numbers am I not allowed to use in this problem? Because if I use these x's, they're going to make zeros on the bottom of fractions. So, what number when I plug in this place right here for the x right here, when it interacts with positive 5, it makes a 0 result on the bottom of the fraction. So what's the only number that's going to do that? Plug in for the x, then I'm going to add 5 to it, and it's going to produce a 0. So what number do you think does that? Well, I hope you said negative 5, because if you did, good job. Okay. And what about this other fraction? What number can I put right here in place of this x so that when I interact with negative 2, it goes that number minus 2 makes 0. So hopefully you said 2, and if you did, good job. Okay. All right, so let's get on with it. So these two are two different fractions, right? They have different bottoms, different denominators. So here's what you're going to do. Okay, and this is going to sound strange because you're going to say we're not subtracting or adding, so why are you making us do this? Okay, but like I said, this is all part of the technique that's going to bring familiarity. So how do I make these two fractions have the same denominator? Is basically what I want to do. Yeah, I want them to each have what each other has. Yeah, so this guy has an x plus 5, this guy has an x minus 2. So what do you think he wants when he starts looking around at other fractions? He's going to say, oh, wow, that fraction has x minus 2. I think I want one of those too. Let's go out and get one. So that's exactly what he does. He goes out and gets x minus 2. And you have to put it on top and bottom, right? You can't just give something on the bottom and not give it to the top. That's not being fair. Yeah. So give an x minus 2 to the top as well. Okay, so when this fraction starts looking around at everybody else, he sees that he has an x plus 5. So what do you think he's going to go out and get? Well, hopefully he said he's going to go out and get an x plus 5 also because, yeah, they like to have the same thing so that they don't get jealous of each other. Okay, so make sure, like I said, whatever you put on the bottom, you put on the top. Okay, and like I said, this is the exact same steps that you would do if this equal sign wasn't there and there was a plus or a minus sign there instead. You do the exact same process that I'm doing right now. Make the denominators match and go from there. Okay, but since this is a solve for x problem, you know it's solve for x because there's an equal sign in there, right? So you're going to solve for x. You're going to get the values of x. Okay, this is where it takes a different turn. So the first step is familiar. The second step is going to be a little bit different. Okay, so your next step is rather gonna be, because they have the same exact denominator, yeah, and this is a solve for x problem when you see an equal sign in between, like in the problem between these fractions, okay, here's what you can do as your next step. Okay, you can cross out all the bottoms, okay, and you can cross them out because they match. If they didn't match on the bottoms, you can't do this step called crossing out the denominators. Okay, but since they do match, you can cross them out and you can continue with what's left. And what is left on the left side? 5 times the quantity x minus 2. And then equals, what's on the right side? 3 times the quantity x plus 5. Okay, and this is all possible because we have the same denominator. And once your denominators match for all your fractions in your problem, you can just go right ahead and cross them all out. So it's good in the future because eventually you're not going to just have one fraction on the left and one fraction on the right. You're going to have maybe like 2 fractions on the left and maybe 3 fractions on the right. And to make this problem easier, you make all the bottoms match. Then once you have all the bottoms match, whether you have 3 fractions, 2 fractions, 5 fractions, yeah, it doesn't matter how many fractions you have. As long as they all have the same denominator, you're allowed to just cross them all out, okay, once they match. Okay, and that's the beauty of this technique. It works with problems that are going to get bigger and bigger in the future as far as the amount of fractions in it. Okay, so then let's just continue on. We're going to distribute the 5, and we're going to get 5x minus 10. You're going to distribute the 3, and you're going to get 3x plus 15. Okay, and then now your pre-alg, alg 1 scales start taking over. You just solve for x, so you send the 3x to the left side because you want to get the x's all by itself on one side. And then you start sending the regular numbers on the other side because you want to make sure you have letters on one side, numbers on the other. So you just start moving things around, yeah, like a chessboard, just move things around. So left side you're going to get 2x, the 10's cancel, equals, the 3x's cancel, 25. Okay, and then you just solve for x. So what's your next step to get the x by itself? You divide by 2. Ooh, I hope that's blue. Let's make sure it's blue. Divide by 2. Yep, it is. And you get x equals 25 over 2. Okay, so in the instructions it says check for extraneous solutions. So here's how you check for extraneous solutions. It's real simple. Okay, you go and walk over to the answer, x equals 25 over 2, and you ask him a simple question. Okay, you ask him this question: are you a negative 5 or are you a 2? Yeah, so is 25 over 2 known as a negative 5 in value or a 2 in value? And if it's not a negative 5 or it's not a 2, then its answer is good to go. Yeah, because your domain restriction says you can have any number for x basically, except which numbers do you have to stay away from? You have to stay away from negative 5 and you have to stay away from 2. Yeah, so the answer that we have here, I mean, it's not really, I mean, you gotta trust that you did the calculations correctly. Yeah, when you check answers, yeah, you're supposed to plug them in. So I'm kind of like giving you a shortcut where I hope you didn't mess up on the solving of the problem, right? Because if you did, then yeah, checking your answer and actually plugging in is going to actually be really, really good. But I'm just going to hope that you guys actually did the computation correctly, right? You distributed the 5 good, you got 5x minus 10. You distributed the 3, you got 3x 15 rather. So I'm gonna assume you didn't mess that up. And if we can make that assumption, then yeah, I let my students get away with checking the answer in this way, where you just pretty much ask, is 25 over 2 one of your domain restrictions? And if it's not, then it should be good to go. Yeah. When the problems get eventually harder, yeah, you probably want to plug it in and stuff, but for now, they're not that bad, so just use this technique. Okay? Alright, hopefully that was enlightening, if math can be enlightening, but yeah, I hope it makes sense, and I'll see you next time. Bye-bye.